Hello everyone, myself Saurabh Maheshwari and I welcome you all to the ongoing lecture series on C programming. We are doing topic functions and in functions we are seeing how the functions recursive work in recursive mode, that is recursion in functions. So till now we have seen that the function main is the first user defined function that is called by compiler, and other user defined functions they that are declared and used in the program are uh, called by main function in the starting. Okay, now when called function 1, so there are definition of function 1. So this is how they are called, but a function can also call itself in some cases in some of the required application. When a function call itself when a function calls itself, so this concept is called recursion. Recursion has many applications, although recursion works similar to loops, as thus loops are used to perform similar tasks repeatedly. So any so in C programming, loops are the functionality that is used to do similar tasks repeatedly, and an alternative of loops in the form of recursion can be done, and it also performs a iterative call of the same function body. Now, similar to loops, there is an important thing to remember in recursion. Since recursion is also iterative, it means when a function keeps on executing, it initiates a call to itself. So this may create a loop among the calls of the function, and this loop, and whenever there is a loop, there is a iteration, the chances of going to infinite is always there. So like loops, you in recursion we also have to look for a terminating condition. So we have to design the recursive function. When a function has a call to itself, this function is called a recursive function. Okay, all the user defined functions are not recursive because they can only perform a simple step by step task, but those functions which have a call to itself, okay, they are called recursive functions. Okay, and recursive functions should be designed, or I can say must be designed in such a way that they comes to a terminating condition, and after this terminating condition recursion stops. Okay, so recursion must stop at terminating condition. Okay, now how does recursion actually performed in memory? So we will see it. This is suppose this is the code block of block 1 of main function. Now we know that every call to a function creates a block of memory, and new set of variables are called here. Okay, new set of variables are created here. So suppose this is function 1. Okay, now this is the simple process where main transfers the control to function performs some task and return the values to the main. So this is the normal processing of any function. Now in recursion, what happens? The main function transfers the control to the function 1, which is a recursive function. So this is block 1. Okay, this is block 1, this is block 2, and this is for main. Now this is for function 1. So this is till now the simple processing, but in a recursive function, a call, while processing of the function, there is a call to the same function. So when the same function is called, there is a loop to the same function. But since this cannot happen in the same block, so what happens? A new block of memory with a copy of instruction and data of the function 1. So the function 1 new instance or new block of memory will be created with the same statements and data that is used by function 1, and the control from function 1 shifts to the recursive call of the function 1. Okay, and if the terminating condition does not reach in this particular call of function, it again leads to the another initiation of block 4, and this would have the same statements and data that is used by function 1, and this is the call to the recursive call to the function 1. So you can see that the same code of function 1 is used, but they have their physical existence. Each copy of code has a physical existence. This is the difference between recursion and loops. Okay, in loops, when you have a iteration where some statements are followed for I equals to 0 to suppose n, so what happens? The same set of instruction, there is only a single block is created. Okay, and this in this block there is only one copy of data and statements. Okay, and all the iterations are performed on same data and statements. But here you can see that every iteration or every call to the recursive functions create a new block of memory, and suppose each of the function has a variable a. So a copy of a instance of a will be created for every physical which will have a physical memory, and it will be created for every recursive call. Okay, so suppose there are, if there are required for iterations are required for 1 to n, suppose there are 5 iterations, so the same data and statements will be used in all the 5 iterations. But if suppose a function goes for 5 recursive calls, so then there would be 5 block of memories, and with 5 different instances of the same variable and statements would be created during the recursion. Now, when the recursion reaches to the terminating condition, it means there is no further level of recursion. So the last level returns to values to the previous level, and then this function remaining statements of the function executes. Then this also returns to the previous level. Then remaining statements are executed, and then finally the first level of recursion returns to the main, and in this way the desired task of the iterative procedure is completed with the help of recursion. So this is the concept of recursion, and it is compared as I have compared it with the loops. We will see more detailed statement of comparison with the loop in upcoming slide. Let us see first one example of finding sum of n natural numbers with the help of recursion. So we have followed this program with the help of loop also, where we can start loop from I equals to 1 and I is less than equals to n and I plus plus, and we can use a variable sum which will be incremented as sum equals to sum plus I in every iteration, and after the complete iteration we can print the sum. So this is a simple loop based solution for the purpose. Okay, and when you apply this loop based solution, only a single instance of sum is created, a single instance of I is created, which keeps the track of the number which is being added, and finally the program leads to some conclusion in the same block. So single block of memory is created. Now we will see how we can perform this with the help of recursion. So here you can see the function int sum of range int is declared with the help of prototype, and here you can see this is the name of the function, and here you can see this is the input data type and this is the output data type. So this is the definition of the function. Those who don't know anything about user defined function should watch my earlier videos on functions before coming to this topic. Okay, now you can see that some variables have been initialized. We will see the use of these variables. You can see input the last number of the range starting from 1. So we are asking here user input about the last number of the series that is to be used, and that is taken in n1. So we are taking input this n, that is the first n natural numbers starting from 1. So this number is passed, the number that is given by input. Suppose the user gives input as 6. Okay, so this 6 is passed through the function. Okay, now if this function is to be created without recursion, then this code could be replaced with this code, and some can be returned. That you can also do while using making this program without recursion. But here using the recursion concept, we can see here that every recursion code must have two things, that is the call to the same function on some conditional call to the same function, and some conditional stop. Okay, so we have to design the condition where we need to stop. So we know that this recursion should stop when this n1 becomes 1. Okay, so this n1 becomes 1. So we have to return 1. Otherwise, we only do that the current number is will be added with the next call to the same function. Now, knowing this code, this does not appears to be a easy method to find the answer manually. Now we will try to do this function for the sample running, and we will try to make how the calls to various function initiates. Okay, so suppose we have started from this and the call has been started. So the first call is I will write the function sum only. Okay, as a sum only, and instead of writing the whole name of function, I will only write sum, and in sum suppose 6 has been given. So this starts from there. So 6 copies first here, then this 6 is having a local variable. This function has a local variable, so a new block from the main, this is main, and from main a new block of memory is created, which is the first call to the sum for 6. Okay, and here a variable res is there and n1 is there. N1 has become 6 and res has been not been used right now. Now res has to be created. So for this sum 6 call, what happens in sum 6 call? The n1, you have to check that whether n1 is equals to 1. So it is not equals to 1. So we will use this notation to write down this, that is n1, that is 6, that is 6 plus, okay, 6 plus we can call sum 5. You can see that the function to the same call has been done. Okay, function to the same call has been done, but with a decrementing. So suppose we want to create sum of 6 plus 5 plus 4 plus 3 plus 2 plus 1. We want to do this summation. So this problem has been broken into some steps, that is 6 plus sum till 5. Okay, then we will go for sum 5 will be uh, tackled like 5 plus sum 4. Okay, and so on. So the a bigger problem is broken into some smaller problems of the same nature. Okay, we will explore more. That is sum 5 would be used as 5 plus sum 4. Okay, now still 4, this 4 is comes in, this 5 came in n1, it is not equal to this if, so the else will run and else will call like this. Then you can see we call for 4, so 4 is again not equal to 1, so it will again call for that is 4 plus some 3, this also a call. Then there is a iterative call of there is a iterative call of 3 plus sum 2, then there is a iterative call of 2 plus sum 1. Now when this sum 1 call happens, so this is 3, 2 and now 1. So value of n1 is 1. So when value of n1 is 1, you return 1. Okay, so the 1 is written. I will write the return value over here, and what will happen, this one will get returned, this one will get returned here. Okay, so this one will get returned, so this value, this sum 2, this particular thing in the function will be replaced with the help of this value, that is 3 plus 1 4. Okay, now after running of this else statement, this return statement would run. Okay, so return statement runs res. So what is the value of res? Res is equals to n1 plus sum of n1 minus 1, and this is the expression that we have used for res. So everywhere I will write now, this was the forward direction and this is the backward direction. So this backward direction would give you res value to 3 plus 1, that is 4. Now this 4 would be returned in place of this sum, so this would become 4 plus 4 8. So this 8 would be returned. This was a forward direction and this is the backward direction. Now this 8 would be value of this. Now this will become 8 plus 5, that is 13. Now 13, this was the forward direction and this is the backward direction. Now this 13 would be returned with the place of this. Okay, this place, that is 13. Now 13 would be 13 and 6 19. Okay, I think I have made some mistake over okay, this 2 plus 1 1 would be returned. Okay, so this 1, there would be a forward direction where nothing will happen, and there would be a backward direction where there would be a backward direction where 1 would be returned, so this would be 1. Okay, this would be 1. So this is 2 plus 1, that is equals to 3. Now this 3 would be returned, so this 3 would be 3 plus 6. Okay, now this 6 would go here. Now 6 plus 4 equals to 10, and then 10 will go here, so this would be 10. 10 plus 5, that would be 15. This 15 would be written here, and 15 plus 6 equals to 21. So in the end, this sum 6 would return 21, and that will be assigned to this sum variable in main. Okay, this sum variable in main. So this sum variable becomes 21 for the value 6 of n1, and this n1, that is 6, with the help of sum are printed in the form of 6 and 21. From 1 to 6 is 21. So in this way, a recursive call is handled. Whenever you want to solve a recursive question, try to make this hierarchical call to the functions where you take one as a forward direction and all the return values in the backward direction. So this is called backtracking also. This is useful for backtracking. It means in loops you cannot backtrack because you don't store the intermediate values, but here you can see that all the intermediate values are also available in the form of the variable res. This res variable in every call gives the intermediate value of the summation. Okay, so this is useful. Recursion is useful in cases where you need to explore the intermediate points also instead of only the answer. Okay, you are not only interested in the answer, but you want to see the intermediate steps also. So in that case, you don't need to use loop, you should use the recursion. Okay, now we will see some differences between recursion and loops. That is, a lot of memory is wasted as a new stack for every call. Here we can see that how the call takes place. Okay, because the compiler starts from main function. Okay, and then it calls for a function one normal call. Okay, so what happens? A stack is created. Stack is nothing but a memory. Okay, those who don't know about stack, you can only remember there is a memory where the information is stored in the terms of last in first out, that is LIFO. That is the information which is put in the last will be taken first out. Okay, so this is kind of a stack of a plates, where the plate that you keep on the top, you will be able to take that plate from the top. You cannot take directly the plate in the last. Okay, so whenever the control transfers from one function to another function, the record of the previous values of the variables is stored in the stack. So the stack is filled from bottom to top. Okay, from bottom to top, in the way that the variables, suppose there are v1, v2, v3, v4, so they are stored in the form of stack. Okay, and whenever the call returns the actual values of, because the compiler needs now to process this function, so it needs to store the values of main somewhere. So it uses this memory to store the values of the calling function. Okay, always the calling function stores its values in the stack. Okay, stack. Fine. So whenever the function one executes and it returns to the calling function, this stack, the values from this stacks are taken, and the main function, the regular processing of main function resumes like that. So this is a simple function call. But what will happen during the call of main and recursive call of function 1? So this new block will be called, the function 1 will be called. So this would be one stack number 1. Okay, so that is used for storage of the main variables of the main function, data items of the main function. Then this function 1 calls iteratively the same function 1, but a new block of memory would be created every time for every call. Now, when this call to take place, the current parameters of the function, when this call of the function will be stored in another stack, that is stack 2. In this example, this res is one of the parameter. Okay, this res is one of the parameter that would be stored in the stack. And even you can have this n1 and other parameters which are in the current call. The value in the current call will be stored. Then function 1, this iteration of function 1 may again call its own, make a recursive call to the same function, and this would be created in a new block of memory. So for doing this, the values of the parameters in this function needs to be stored in another stack S3. Okay, now when this function ends, it returns. Okay, it returns, and when it returns, the values that were stored in the stack are taken back by the function, by the compiler. Okay, to make the parameter to take the parameters values. Okay, and in this way this stack is used, and this stack is the reason that this recursion is used for backtracking, because all the variables that have been created during the forward call are stored in the stack. So while coming in the backward direction, while backtracking, these variable values can be accessed from the stack. So all the values remain available for the usage, and that is why recursion is useful. But a lot of memory is wasted in this process. This might be taken as disadvantage of recursion, because in every recursive step a new stack is created and it is sort of a memory. So memory and different block of memories are also created in loops, while only one block of memory is created with a single instance of the code in a loop. So there the memory is not wasted, and here you can see that different blocks of memory is created, so it wastes some memory. So whenever you are in very deficiency of the memory, we should not use recursion, we should use loop. We have also seen that it is useful. I'm writing whether it is disadvantage of recursion or advantage of recursion. So advantage of recursion is that useful for backtracking, as all the intermediate values remain alive in memory. So memory is stacked here. So you have seen that how the backtracking is feasible with the help of recursion, where the intermediate values are stored in the stacks and they can be accessed while backtracking. Okay, now recursion and loops both are risky if proper termination condition is not there. Okay, like in this example, if we have not written this particular condition, that is where to stop, and we have not returned a constant value here, so what would have happened? This function would have lead to infinite calls, and that would make a problem. For the same happens with the loop. Okay, but in the but in the recursion, what happens in the loop? What happens? Only the memory is exhausted. Okay, in the loop which is infinite. In the infinite loop, only memory is exhausted, and memory is exhausted if you have created an infinite loop and you try to run it for infinite times, so only memory will be exhausting and compiler may crash. Okay, and compiler may crash. But for if recursion is infinite, if you have created an infinite recursion, that may cause your CPU to crash. Okay, so we have to remember that we should not go for infinite recursions. Okay, so this may be taken as advantage and disadvantage both. Okay, so I would not say advantage, you have to take it disadvantage. Now in loop, same variables are changed every time, so no backtracking, but very less memory is used. Okay, so this is a disadvantage, that backtracking with loops is not capable of doing with the help of loops. Okay, but very less memory is used while we implement with the help of loop. Okay, so there one thing you have to remember, that there is no problem that can be solved with help of recursion, and that cannot be solved with the help of loop. Okay, so loops and recursions are logically trade-off between each other. That is, they both are alternatives to each other for different condition. Whenever you want to backtrack, you should use recursion, and otherwise, if backtracking is not required and you don't want intermediate values, then you can simply use loop. And also, if you have abundant memory, then you should use recursion, because it makes the code recursion codes are easy to write, and they look simpler. Okay, places where branching exists. Okay, whenever there is a sort of branching that we have seen here in this example, that we do some branching over there based on the conditions. So in these cases, recursion is simpler to use, and there is a easier debug code available. But recursion codes are difficult to debug, because to get the values you have to perform you have to go for every branch to get the actual value of the recursion. Okay, recursion is also useful when there is a complex problem and that can be solved with a small set of same problems. This is the statement what we have done here. A bigger problem has been divided into a smaller problem of addition of the remaining problem. So in this way, the complex problems can be broken into some set of same small problems. The word small and same is important because the same problems would lead to recursion. Otherwise, if the problems are different, you cannot perform recursion. Okay. Now, since same code of work on different memory stacks or blocks, so parallel processing may be there. So this is one of the advantage of the recursion because loops are work on the same memory. It means all the data and instruction are available in the same memory. So you cannot do parallel processing where different processors can process simultaneously on the data. But since data is common, so there is a problem of deadlock. The recursion can the compiler cannot work on the same data parallelly with different processors. But here in this recursion, we have different physical memories, and the data is in multiple copies. So what can be done that CPU 1 can be used to assign this task, CPU 2 can be assigned to do this task, CPU 3 can assign to this task, and all these tasks can be done parallelly. Okay, and this may make the processing fast. So whenever you want to use parallel processing, recursion can be a good idea. Okay, now this is one of the advantage, this is one of the advantage, and this is one of the advantage, but this is one of the disadvantage, that since you have to backtrack, so you this becomes difficult to debug. Whenever there is a problem, you have to debug the whole chain. So whole chain debugging is always difficult if there are multiple recursive calls. Okay, and loops will be executed faster than recursion. This is quite obvious because every time whenever there is a call to the function, a stack is created, and whenever you return, you have to take these values from the stack back. Okay, now this process takes extra time. In the loop there is no such problem. Loop is simply goes in the forward direction and checks the condition, and if the condition is true, then again start processing in the same direction, and the same process goes over again and again till this condition is uh, true. Okay, but in recursion, every time when a call is there, a new memory has to be created, and whenever there is return, the values from the memory to be taken back. This process may take some extra time, and that is why loops are always faster than recursion. Okay, in loops, same variables are so no backtracking is there. So this is disadvantage of loop. Okay, so this is the difference between loop and this is the difference between loop and recursion. We will see the use of static keyword in the next video. Till then, stay safe, stay healthy. Thank you.